Have you ever wondered how the Chinese Air Force revitalized its 310 aging J-10A fighters, even making them nearly match the combat capabilities of the latest J-10C, amid the relentless pressure from surrounding F-16V and Rafale fighters? Behind this lies a deep retrofit project codenamed J-10A. Far more than a simple weapons upgrade, it represents a comprehensive overhaul involving avionics, power systems, and weaponry, a pragmatic and efficient choice by the PLAF navigating complex geopolitical realities. As China's domestically developed third-generation fighter, the J-10A entered mass production in 2006 and ceased production in 2014, with approximately 310 units manufactured. This includes 220 single-seat variants for the Air Force, 20 naval adaptation models, and 70 dual-seat trainer versions. Featuring a distinctive canard configuration paired with high-thrust turbofan engines, it achieves a maximum speed of Mach 2 with an operational radius exceeding 1,000 kilometers. Its exceptional maneuverability rivaled that of the U.S. Air Force's F-16V at the time, making it a backbone force defending China's airspace for over a decade. However, as the regional security environment grew increasingly complex, with Taiwan accelerating its F-16V upgrades and introducing ESA radars, and the Indian Air Force deploying Rafale fighters in volume, the J-10A's original technical specifications began to show limitations. Its pulse Doppler radar has a lock-on range of only 140 kilometers, and its primary armament is limited to PL-8 short-range dogfight missiles and PL-12 medium-range air-to-air missiles, making it difficult to achieve first-fire advantage in beyond visual range combat. Deeper pressures stem from the broader strategic landscape. The U.S. continues advancing its Indo-Pacific strategy, with its single-theater concept proposed jointly with Japan, aiming to integrate the Korean Peninsula, East China Sea, Taiwan Strait, and South China Sea into a unified operational theater. By deepening military cooperation with Japan, the Philippines, Australia, and others, it seeks to build a comprehensive deterrence system targeting China. Simultaneously, Japan actively promotes the Japan-US Plus and military cooperation framework, frequently conducting joint exercises with multiple partners across the Asia-Pacific to forge a containment network akin to an Asia-Pacific NATO. Against this backdrop, the Chinese Air Force must sustain routine patrols and border interception missions while preparing for potential high-intensity military confrontations, ensuring full-spectrum capabilities from near-sea defense to distant ocean escort operations. Although new fighters like the J-20 and J-16 have formed the core strike force, a full fleet upgrade is costly and time-consuming. Therefore, modernizing the existing J-10A fleet to rapidly enhance overall combat effectiveness at a lower cost has become a strategic choice balancing practicality and efficiency. In early 2025, the aviation industry formally launched the full series upgrade program for the J-10A, designated J-10AG. This upgrade is not a minor tweak, but focuses on three core modules: avionics, power systems, and weapon payloads. The goal is to enable a smooth transition from late fourth generation to fourth and a half generation capabilities. The upgrade program began with a comprehensive technical assessment, conducting airframe fatigue inspections and system interface reviews on all aircraft. The first batch of test aircraft selected two-seat J-10S fighters from the Eastern Theater Command, chosen for their relatively short service history and extensive flight data, facilitating iterative validation. The avionics system overhaul is the cornerstone of this upgrade. The original KLJ-3 pulse Doppler radar on the J-10A had a narrow scanning range and weak anti-jamming capabilities. Its communication system lacked real-time data link support, and the fire control system was compatible with only a limited range of munitions. The J-10AG, benchmarked against the J-10C, was retrofitted with a new active phased array radar capable of simultaneously tracking 20 targets and engaging 6 of them. During the upgrade, engineers first replaced the communication, navigation, and fire control modules, introducing an integrated display and helmet-mounted sighting system. After static adaptation at the Xi'an Yanliang base, where voltage and thermal control parameters were calibrated, the aircraft moved to the Chengdu company for dynamic bay testing. This ensured the full-motion canards would not generate harmful vibrations during high-speed flight. Finally, through unloaded test flights with progressively loaded signals, system stability was verified. Following the upgrade, pilots can now access multi-screen fusion displays within the cockpit, simultaneously presenting radar, infrared search and track system, and data link information. This reduces target identification time to under 5 seconds. The expansion of its weapons systems has significantly enhanced its lethality. The J-10A has optimized its original 11 external hardpoints, enabling compatibility with both the PL-10 high maneuverability close-range air-to-air missile and the PL-15 long-range air-to-air missile. The integration of the PL-15 marks a revolutionary advancement, boasting a range of 200 kilometers. It employs a dual-pulse solid-fuel rocket motor and an active radar seeker. Not only is it interoperable with the J-20's munitions, but it also achieves fire-and-forget capability post-launch, eliminating the need for continuous radar tracking by the carrier aircraft. This makes it exceptionally difficult for enemy aircraft to evade through conventional maneuvers. Simulation data indicates that J-10A formations equipped with these new weapons achieved an 88% hit rate in beyond visual range air combat, demonstrating a clear advantage even against simulated fourth-and-a-half-generation fighters like the Rafale. The powerplant upgrade represents another core advancement. The J-10's original L-31F engine delivered 12 tons of thrust but required frequent maintenance and faced supply chain uncertainties. The J-10A now features the domestically produced WS-10B engine, boosting afterburner thrust to 13 tons, improving thermal efficiency by 10%, and extending mean time between failures by nearly 2,000 hours. The new fully digital control system boasts a response time of just 0.1 seconds. By optimizing the thrust curve, the fighter's climb rate has increased by 20%. During testing, the J-10A's operational range expanded from 1,500 kilometers to 1,800 kilometers. Its maneuvering radius increased by 15%, and its power supply capacity doubled, sufficient to support the stable operation of next-generation high-power avionics systems. Particularly noteworthy is the modular upgrade strategy adopted throughout the program, which avoided grounding the entire fleet for modifications. By the first half of 2025, 70 pilot aircraft had been upgraded, including naval aviation variants undergoing carrier adaptation verification. Subsequent upgrades will be tailored to theater-specific requirements. The Eastern Theater Command prioritizes air superiority, while the Southern Theater Command enhances maritime strike capabilities. The upgrade cost per aircraft is approximately 60 million yuan, equivalent to only 65% of the cost of a new J-10C. Post-upgrade, the domestic content rate reaches 95%. By adopting advanced manufacturing techniques like 3D printing, the upgrade cycle has been shortened by 30%. Combined with dedicated simulation training stations, this has effectively accelerated the integration of pilots with the new equipment. To date, approximately 150 J-10A's have been upgraded. The first batch delivered to the Southern Theater Command has commenced routine patrols over the South China Sea, validating the PL-15 missile's stability in high-temperature, high-humidity conditions. The remaining 160 aircraft are scheduled for completion by spring 2026. This initiative not only saves tens of billions in military expenditures but also significantly bolsters the PLA Air Force's strategic presence in the Asia-Pacific region. This large-scale upgrade has also drawn international attention, particularly regarding the export potential of the J-10 series. Pakistan, as China's traditional defense partner, introduced the J-10CE in 2022 and achieved combat results with this model during the May 2025 India-Pakistan conflict. It is reported to have placed an additional order for 30 aircraft. Meanwhile, constrained by sanctions, China has refrained from exporting fighters to North Korea to uphold its international obligations. Compounding this, Pyongyang's military focus remains concentrated on nuclear and missile programs, while its economic capacity cannot support the procurement and maintenance of advanced fighter systems. Consequently, the likelihood of J-10A or its derivatives being exported to North Korea in the near term is extremely low. The evolution from the J-10A to the J-10A represents more than a technical upgrade for a single aircraft model. It embodies a precise strategic decision by the Chinese Air Force, grounded in its industrial capabilities and strategic requirements, to counter strategic encirclement. This initiative has revitalized a fleet of veteran aircraft that once earned distinguished service, enabling them to regain their edge in the new strategic landscape. With limited investment, it has significantly enhanced the overall resilience of the Air Force's combat capabilities. In the Asia-Pacific skies, where powerful rivals abound, this development has introduced a crucial element of certainty to the maintenance of regional strategic equilibrium.